Hello and welcome everyone. We're really excited to have you here today for a weekly deep dive series with OCI Product Management. For anyone who might be new to these events, we are hosted on Cloud Customer Connect, which is our Oracle community forum for end users. You'll see links in the chat throughout the presentation today that lead you back to the CCC forums. And if you haven't already, we invite you to create a free account, join in discussions, and look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today I'm joined by Viji Krishnamurthy, Senior Director of Product Management, and Jason Ding, Principal Data Scientist here at OCI. They're going to introduce and demo our just released OCI Anomaly Detection Service, which will help you easily incorporate scalable AI-based remote asset monitoring and diagnostic features into your workflow. Before I hand things over to Viji and Jason, I do want to run one quick poll. Those of you who have been with us before might recognize this. We build these weekly deep dives with you, our customers, in mind. So please take a moment to share your thoughts on what topics interest you the most, and I will use that to build future events. Speaking of which, next Thursday, we have an event on the 12th. We're hosting Somnath Lahiri to showcase how to use the Kafka-compatible Oracle streaming service to build event-driven architecture. I will drop a link to that registration page in the chat, and I hope you can join us for that as well. I'm also going to drop a link to a survey that we're running. We appreciate your opinions and your feedback. So if you have 1 or 2 moments at some point to give us that, we really appreciate hearing from you. And our usual reminders, please use that Q&A box down at the bottom of your Zoom screen for any questions. You can drop those questions in there throughout the presentation. Folks will be answering them, and then we'll have some time at the end for some live Q&A as well. And we are recording, as mentioned, so if you have colleagues or friends that you think might be interested in this, we'll be reposting this up on the forums as well for future replays and more information too. All right, I think that is quite enough for me. Take it away, Viji.
Thank you, Kenna. Good morning, everyone, and thank you for taking time to meet with us today. I'm going to talk about OCI Anomaly Detection Service, and before introducing that particular product, I want to quickly give you a rundown of the entire OCI portfolio so that you understand how this particular OCI Anomaly Detection AI service is actually helping in addition to the portfolio of products that we have. OCI Anomaly Detection Service is actually part of the AI services portfolio within our OCI portfolio. The AI services actually are released in 4 different pillars: speech, vision, language, and decision. Speech is, speech, vision, language, or perceptual pillars, and the decision deals with all structured data and how to derive insights out of that structured data. Anomaly detection is part of the decision pillar, and today Jason and I will be talking about anomaly detection. We do have a language service released as well. It's G8, and we'll have a webcast in the future about the language service. Vision is in beta. We'll have a webcast on that as well. So I would really highly recommend you to attend those webcasts if you're interested in using those services for some of the business problems that you're working on. With that, let's look at what are the 2 primary value deliveries of anomaly detection. The first value delivery that we are targeting with OCI Anomaly Detection is helping our customers identify unusual business patterns. It could be on their business performance metrics, sensor signals that they are collecting from their connected assets. It could be transactional data, timestamped transactional data that they're collecting. Our goal is to help our customers to identify those unusual patterns automatically so that sufficient resource can be assigned to address those unusual patterns before they result in business disruption. The second value delivery from OCI Anomaly Detection is helping our customers to transform from dashboards into actionable insights. As you know, we have a lot of connected devices now. If you're running a manufacturing or transportation or asset monitoring related business, you have assets that are connected and collecting data in real time. Typically, most of these assets are managed from the perspective of what is its performance in a time window. Say, like, what is the performance in the last 1 hour? And generally, that performance metrics is calculated as a statistics on the data collected, like what is the minimum, what is the maximum, what's the average value of the throughput, or what is the average yield loss, those sort of information. So the reason that those dashboards do not really deliver you a full value of the connected asset is because the dashboards expect the customer who's viewing the dashboard to figure out whether this is normal or abnormal and make actionable a decision based on that. What we want to do with OCI anomaly detection is that how do we really transform those dashboards with identified anomalies so that the user is actually can immediately jump into identifying what kind of action that he or she needs to take to resolve those anomalies. So if you are having any dashboard that tracks minimum, maximum, average count of any performance metrics that are based on the time series data, OCI anomaly detection is for you. To actually immediately use it to transform those dashboards into number of anomalies identified, the type of anomalies identified, the severity of the anomalies identified, so that you could take action on them and you could prioritize those actions as well based on the severity. So given that, what is OCI anomaly detection? It's a managed service, and it helps you to build custom model based on your own data. Say you have data on if you're a banking customer, you have data on your banking transactions or the ATMs. If you're a oil and gas customer, you have oil and gas assets. Similarly, your utility assets or your manufacturing assets or transportation assets. What it helps you to do is take your own historical data and help you to build custom model based on the data so that you could identify anomalies on those asset performance as you collect a new data. This anomaly detection service includes one of our really well-researched innovations called MSET2. You probably have heard of MSET, which is one of the algorithms that is in the market for over 2 decades. And it's actually used pretty much in all of the nuclear power plants and majority of the utility and oil and gas sector companies. The MSET algorithm actually works really well when you have complex assets with signals that are interconnected, interrelated, and it actually takes advantage of the interrelationship between those signals to identify anomalous behavior at the earliest possible time. And that's exactly what is needed when you're collecting large amount of data from different assets, and you want to identify the potential business disruption based on those data. So that's why we have actually our innovator, who's innovator of the MSET2, actually, he has upgraded the MSET algorithm with additional innovations that we have incorporated as a part of this service. Having said that, your question would be like, what are the differentiators of this service? Like, what is different from in OCI anomaly detection compared to what's in the market, either open source or in the competitors' portfolio? There are 3 differentiators that I want to highlight. One is OCI anomaly detection automatically pre-processes the data. So if you have worked with any time series data, you know how difficult it is to really get a good quality data, because you do end up with missing values because of dropped signals. You end up with difference in the time frequency, because some signals are coming at 5-minute interval, some signals are coming at 7-minute interval, which results in the sparsity in the data. And you also end up with some quantized signals. Certain signals are coming at a specific value, not as a continuous value, because they are aggregating at the edge. So these issues are automatically identified by OCI anomaly detection and automatically fixed before the model is trained, so that we can end up with the best model with the highest accuracy possible. That's one differentiator. The second differentiator is that the service is built from developer's perspective, developer and the business user's perspective. So when the model is, when you trigger the model training, you are asked what is the ideal false alarm probability that you need for the model to be applicable for the business problem that you're working on. And other than that, all the data science aspects of building the best model, optimizing the hyperparameters, all of that is automated within the service. So the user of the service is not expected to be a data scientist. Furthermore, user of the service is not expected to really figure out how to scale up and scale down the compute, because it's a completely managed service. So depending on the size of the data, we automatically scale up and scale down to ensure that you're getting the best model that you need within the time period that is ideal. The other aspect of the model training is that when you do get a model that is completed the training, you get the model output that is easily interpretable to understand whether this model is the right model for your business problem. It includes the overall model accuracy. It also gives you the specific signal accuracy. Maybe you have in your asset, you're collecting 50 signals, but maybe 5 or 6 of them are very critical for business. And you would want to know what is the accuracy of this model on those signals, as well as the overall accuracy. So we do provide that as a part of the model output. We also give you the statistics on every signal. For example, what percent is imputed for missing value, whether the signal is actually dropped or included in the model. And if it is dropped, what is the reason for dropping? So these information help you to figure out if in case the model is not actually acceptable, it doesn't have the right accuracy for your business problem, you could easily figure out what are the quality issues, data quality issues that you need to focus on so that you could build a better model with a new set of data. So that is the second differentiator. It's actually built from developer business user perspective. So as a developer, you can take the result of the OCI anomaly detection and then provide it to your business user in your solution, so that the business user can review and then figure out whether they want to build with a different set of data. The third differentiator is it helps you to automate the business workflows. How, when we do identify anomaly, say for example, you have built a model, you like the model, and now you're sending the freshly collected data to the model, and you want to know whether there are anomalies in those freshly collected data. We do provide for every anomaly identified, what is the estimated value based on the machine learning model. And it gives you the sense of what is the severity. Say, for example, you're expecting an estimated value of the temperature is 25, but the actual value is 136. It gives you a sense of whether how severe is the anomaly, so that you could assign the severity level and then figure out what is the downstream business workflow that need to be executed on it. The second output that we give is what is the aggregated score over time. So, for example, let's say that you're monitoring an asset continuously 24/7. You could actually see, right now you have an anomaly, but is that anomaly worse? Is the aggregated score of that anomaly worse than a minute before, or 2 minutes before, 5 minutes before? Is it actually trending in the direction that is disruptive for the business, or is it actually going up and down? So you could actually use the anomaly score to assess whether the anomalies are becoming worse as the time passes. The third is we also provide you signal specific score. Let's say that at a particular time, say 10:30 a.m., you have 3 different signals that are anomalous. We provide you the relative severity of those signals so that you could understand which one is the worst performing in terms of the anomalies, and then decide what is the downstream business workflows that needs to be automated based on that. So those are the 3 aspects, like the way that we see our customers use these aggregated score and the signal specific score, as well as the estimated value, is that they do have rules based on the difference between the estimated and the actual, and the rules based on whether incrementally whether the aggregated score is increasing, and also identifying which is whether one of the critical signals are having the worst anomaly in the signal specific score, and based on that they assign the severity between 1 to 5, and then automate what is the downstream action need to be taken. For example, if it's a high severity, assign a technician; low severity, raise a warning, but continue to observe. So those kind of downstream business workflow is what our customers do with these kind of output for every anomaly that we identify. So with that, let me hand it over to Jason, who's our principal data scientist, to give you a demo of one of the use cases with OCI Anomaly Detection.
Thank you, Viji. Hey, everyone. This is Jason Dean. I'm one of the data scientists at OCI to help building anomaly detect product. So I would like to show you a case study that how to use our product to detect anomaly events in one business case. Okay, so the problem we have is basically there's IoT companies, they have sensors deployed in many business assets that monitor chemical plants. The chemical plants occasionally have service interruptions due to some machinery breakdown or power outage, etc. And then they have to send someone to look into the issue and fix it as soon as possible. They have used a traditional thresholding approach to alert such events, but those thresholds are too rigid and often generate a lot of false positives. So our goal here is help them to build more intelligent solutions to alert those anomalies with low false positive and also alert as early as possible by using the machine learning model that's built from our platform. So we work with the client to prepare the data in order to use our product. So we identify 10 signals from different sensors, marrying the flow of water, chemicals as a metrics as well. And we were using one period from November in 2018 to middle of December 2018, because in those times, the system are running in normal conditions. The sampling intervals for those sensors is relatively 1 minute, but this is not required. So you can have different frequencies from different sensors. And like we just said earlier, we automatically align them well and send to the service to build the model. So the bottom, you can see the data example. The first column is a timestamp, and then the rest of them basically are the sensor values. This is a CSV format, right? You can easily, have it created from the data source. And our service also support other type of data format like JSON format, and also from like database as well. So you can reference our documentation to see what's being supported and what the format should be looking like. So now I'm gonna run the demo to show you how to use our product to help this business case. Let me share the screen. So first, when you log into the Cloud Console, you can navigate to our product in the analytics on the AI menu on the AI services section. And once you come down here, you can create a project. And often if you say exclamation mark here, then that means that the tenants and admin need to give you permission to create policies, allow you to use our service. So, so far I'm already admin, so I can directly start creating a project. You can give a sample name and that's it, right? So the project essentially is a place to have all the models and data assets, so you can have a single place to work for one project. So since I already created a demo project, so I'm gonna jump into it. So after you get into a project, right, build any machine learning models, we need data, right? So the first part is basically you need to upload your data to somewhere, either in the database or object storage. So in this case, I'm gonna use the Oracle Object Storage. So you can jump into the storage bucket service, right? Upload the data from your local machine. And you can create a bucket, or if you already have existing bucket, you can leverage that. I already have one, so I can upload the CSV file that I showed up earlier and select upload. So since I already uploaded here, so I can skip for now. So the data is here. So now we can come back to the data asset part in the anomaly detection page, where you can start create data assets and give a simple name. And then the tab, you can choose object storage, because I use object storage to upload the training data, right? As you can see, we also support Oracle Automated Transaction Processing and InfluxDB as well, right? And then you can select the bucket where the data has been located, and the training data is this one, and just create. So the data assets is kind of a referencing to the original, the raw data source. And later, when doing the model, when creating the model, you can reference these data assets to build the model, right? So now I have these data assets being created. So I will go back to the model page and creating and training a model. So when click the button, then you can say, wait, I need to select which assets I can select. So since I already created a sample assets, I will pick this one. And next step, I will give a name. And then we also have two parameters to set. One is targeted false alert probability. Because we require the data is clean, is anomaly free. So we want to have a really low value to allow the model to train as accurate as possible, right? So we want to set a, let's say 0.01, which means 1%, we only allow up to 1% of false alert. And for training factor ratio, so we split the data internally into training part and testing part, which is a really standard approach in many machine learning life cycle, right? So here I'm going to use 0.7, meaning 70% of data is training, the rest 30% is testing, so that after the model building, we can report what is the performance of the model we have built. And then next, and then you verify all the information are correct, we can create the model. So at this time, the model will kick it off in the backend. They are, use of MSAT2 method and also other data preprocessing algorithm, so that it will start training in the backend, right? Due to the time limitation, I'm gonna use a pre-existing model that's already built earlier, and to show you how to do detection. So once the model is trained, it's active, you can start detect anomaly in newer data, right? So like me, again, you can use CSV file or JSON file, a family local machine. So I'd have a detect payload here. I'm gonna upload and run the detection. It just take almost a second or two and to show up the results, okay? Like Viji said earlier, right? In the results, we show the actual value of the signal and also estimated value. In this case, we found there's two signals in the data set had anomaly been generated, right? So we show this to subgraph to show each of these two signals, and which part, the red line is meaning there's anomaly detected in that timestamp. And then the black line is basically the actual value. And then there's a green line here showing the estimate value that is a value estimated by the model. So you can say, we have detected some anomaly, and this one, you can, on the right-hand side, you see the anomaly is kind of across different signal. And the first one, it's only happening on the first signal, set point signal, right? So this is a multivariate time series anomaly detection. So if there's correlation between the signal, but the pattern show differently, so the algorithm is able to capture it and show the anomaly. And like Viji mentioned, we also operate a score at at the aggregate level that cross different timestamps to show you how severe the anomaly is. You can integrate it with your business pipeline to judge should you send someone alert to this is a high priority or not, right, based on the scores, right? So this is the UI rendering of the results. We also have the API response that give you more detailed results. So I'm going to show you the model training response, like Viji mentioned. So we give you some statistics about the signal and the min max value and whether being accepted or or some issues. And the right hand side is the detection response. Like I said earlier, right? We give you the estimated value. Sometimes if there's missing value, we do imputation automatically, and also show you what is the imputed value and what is the score. And in the meantime, we also give you a score at that timestamp that's combined the multiple anomaly in that timestamp across different signals. So this is the model response. And then finally, like I said, we also have the API response. so that you can integrate with your OCI Click tool or SDK that's directly integrated with your in your pipeline. And all this process we have documented in our labs at Oracle. You can follow through these steps to easily learn how to do this model development using our product, and in a really easy way, right? So you just need to follow the steps and go through it, and you will understand how it works and how this can apply into your business case. So this is the end of the demo. Thank you.
Thank you, Jason. So we just looked at the demo. Let me talk about some of the use cases that we have been working on with a variety of customers to give you an idea on how OCI anomaly detection can be used. So anomaly detection, as you know, is pretty, widely usable, right? If you're in a banking sector or a finance and insurance sector, you can imagine doing anomaly detection on the abnormal purchases, deposits, fraudulent spend claims, and things like that. And you could also be doing it on your assets like ATM health, whether the ATM or the ATM booth, whether there are abnormal number of visitors, or the different card, like non-bank card is used in the ATM. Those kind of use cases you could do in the banking. Telecom is also, you could do from the service level perspective, you could do quite a number of anomaly detection based use cases to identify whether there are any potential service disruptions based on the signals that you're collecting from the assets. From healthcare also, there's quite a number of payments, claims focused fraudulent behaviors that can be identified using anomaly detection. Manufacturing has quite a number of use cases from both product quality, operational efficiency, factory uptime. Transportation has a lot of use cases from the vehicle behavior as well as the shipment delays. And oil and gas and utility, because they have remote assets and they are typically connected, you immediately have quite a number of use cases on how you can monitor those remote assets using anomaly detection. So typically, any time series data that you're collecting from any of your business resources, it could be connected assets or the transactional information that is collected on your enterprise applications, give you opportunity to apply anomaly detection to go from understanding statistics of the performance metrics to identifying abnormal performance metrics so that you could take action on them. We have been in a limited availability since March, and we GA'd this. We made this product general availability in the middle of July. So we have been engaging with quite a number of customers, and these are a small set of examples of those customers. And while I'm presenting, please answer this polling questions to help us understand whether you would like to have a hands-on training sometime in the future. So some of the use cases that we are coming across are, we have been working with customers or, monitoring wind turbine power plants, monitoring residential, assets like HVAC and energy consumption, kind of assets on whether there are abnormal energy consumption, and also doing stock portfolio, like you have a portfolio that is you want to know whether the price of the stock is actually anomalous compared to some of the fundamentals and that you're monitoring. We also have we've been working with one of the catamaran racing customer who's actually monitoring their catamarans on their health to see whether there is opportunity for any mishaps. And we are also working. One of the examples that I want to highlight here is the utility and oil and gas sector. We see a lot of opportunities and a lot of engagements where if you have a multi-site energy production or multi-site oil and gas kind of a business, how do you monitor the remote assets, and how do you identify actionable outcomes from those data that is collected from the connected devices. With that, let me share the poll before moving to the next slide. Going to the, we have a reference that I want to quickly highlight. SS Global is our reference, who actually, they have an IoT application for fleet monitoring called iSensey.io. That particular IoT application collects data from the vehicles directly, vehicle, tire temperature, tire tread, and tire pressure, ambient temperature. All of this information is collected from the vehicle to identify whether there is any tire-related issues that they have to pay attention to, and that real-time data is fed to their IoT application, and anomaly detection is applied within their IoT application iSensey.io to create incidents, business workflows with a certain level of severity for the technician or the driver to pay attention to. They have the same iSensey.io for cargo monitoring as well. Like, if the vehicle is connected to a cargo, let's say refrigerated cargo, and you can monitor the refrigeration condition to ensure that you can meet the regulatory guidelines on maintaining a specific temperature condition for meat products or the perishables. So during the transit, so that the product is actually delivered in the right condition to the customer. So with that, I want to quickly delve into three focus segments for us to give you an idea on what kind of use cases that we are working with customers on. One is in manufacturing. In manufacturing, we see a lot of traction, mainly because, as you know, during COVID, we all have moved into remote workplace and remote workforce kind of situation where we've had customers, like, some of our Oracle's customers have actually been monitoring their production facility remotely and collecting data and identifying productivity issues and addressing them. So anomaly detection falls squarely into that kind of a use case where we could actually help the customers to not only collect the data and enable them to look at the statistics of the collected data, like a productivity or yield or utilization, capacity utilization, or the inventory level. We could actually say whether there is an anomalous amount of inventory before a particular station on a Tuesday morning, compared to the historical performance. That way they can actually take action on them as needed. And we do see a lot of manufacturers that we're working with, or going into, like, they have actually accelerated the digitization projects by either utilizing already connected devices, connected assets for collecting information, or taking steps to actually instrument some of the traditional equipments and automated material handling systems to really collect real-time data so that they could analyze those data. With that, there are four use cases that are extremely prevalent in manufacturing that we come across. One is operational efficiency, like monitoring day-to-day performance of the manufacturing line, production line, or the factory, and comparing that across the factories to identify whether there are anomalous behaviors in a specific factory that is resulting in potential shipment delays. Product quality is the second area that we find quite a number of engagement, particularly understanding anomalies in scraps and reworks and yield losses. And then the third is this factory uptime, like, understanding the overall equipment effectiveness or downtime, whether the utilization of the equipment, a single equipment or the entire production line, or there changes, anomalous behaviors in the health of the equipment that could lead to the unexpected failure. That's one large area we see a lot of engagement. The fourth is the inventory level, understanding whether the inventory is depleting faster than usual or slower than the usual when it comes to raw material, or the finished goods inventory. Is there a pileup because there is a potential shipment delay? Those kind of use cases are also pretty prevalent. So if you're managing a manufacturing business, we would love to work with you to see how we can take one of these use cases and then help you to see how you can derive value out of the OCI anomaly detection. The next sector that I want to talk about is transportation. Transportation, again, as you know, during COVID, transportation completely got disrupted in terms of, and also it had downstream effect on the entire supply chain, the global supply chain. So one of the things that we see again here is that ability to have a continuous data collected from the vehicles as well as from the cargo, so that they could actually prevent any shipment delays or any disruption to the shipment plan that both the third-party logistics companies as well as the fleet owners have committed to the respective customers. So if you look at transportation, there are three broad set of use cases that emerge that we work on. We work with a variety of customers. One is vehicle monitoring. What is my vehicle health? A vehicle condition, is it going to have any kind of disruption that I need to pay attention to? Can I do that? Can I learn that ahead of time so that I can avoid any trip delays and the issues related to the vehicle that we have to figure out how to expedite some of the shipments that are delayed. So here we have quite a number of, as I mentioned, the SS Global is one of the use cases where they actually do quite a number of vehicle monitoring focus, like both tire as well as the vehicle itself, like the engine temperature, engine pressure, things like that. Also, they have sensors with which you can collect those information and help to monitor the vehicle. The second is refrigeration prognostics. Again, what is the cargo condition, and the focus is on the wastage. How do I avoid the wastage, and how do I make sure that the product is shipped at the right condition at the right time to the end customer? The third is the driver safety. As you know, in most of the countries as well as states, there is mandate on collecting electronic data logging to ensure that the drivers are actually working only certain number of hours for their own safety. We see use cases where some of these, traditionally these hours of service is collected and then the EDL, electronic data logging report is generated, and someone is reviewing that report to ensure that everything is under compliance. But there are use cases that we are storyboarding with some customers where they want to actually do a proactive analysis of the data that as and when the drivers are logging, either automatically or manually, to ensure that the data is compliant, instead of just doing it as a post analysis based on the report. So these are the three broad sectors that we see in the transportation. The third and the last focus vertical that I want to talk about is asset monitoring. Asset monitoring is, as you know, it encompasses quite a number of market vertical. For example, your telecommunication sector where you have remote assets, your oil and gas where you have remote assets or on-premise assets, your utility sector, your banking sector where you have where you're monitoring your asset could be your branch as well as your ATM booth. So asset monitoring is pretty much encompasses all of this. Wherever you are collecting data from your remote business asset, it could be a physical asset or it could be a business entity that you're collecting data on. If that is a timestamp data, you could use anomaly detection to identify what is its current performance. Is the current performance acceptable, or if it is abnormal, what kind of severity that you're seeing and how to take action on that. So in this case, we basically see three broad type of use cases. One is asset performance focused, is my telecom, tower, what is its service metrics? Is it actually logging the right kind of metrics? Are there any anomalies? Or the production metrics, like for example, if you're actually producing something from that asset, is it actually producing the right kind of metrics related to your business goals? So the asset performance focused is one type of use case that we see. The second is asset condition. Is my asset in the right condition? Is it, what are its health metrics, whether it is having any uptime issues, downtime issues, those sort of asset condition focused use cases are also quite prevalent in this sector. And the third is the fraud or the wastage, like, are there any abuse? If you're talking about telecom sector, like, are there any service abuse? If you're talking about utility or oil and gas, are there any wastages that you can monitor, to ensure that you're actually able to reduce your overall cost of producing or serving your customers while maintaining the optimal asset condition and asset performance. So that's what we see as the typical use cases in the asset monitoring. With that, I want to quickly run down OCI anomaly detection as a service is going to grow quite a bit over the next 6 to 18 months. And I want to give you a sense of, because anomaly detection is a very significant type of deployment in any of the businesses. And we understand how significant it is in your business. And we are actually working on adding quite a number of capabilities to the service as we move forward. What we have right now is a multivariate time series anomaly detection, which is what is GA already. You can use it today. And if you need any support from us for running a pilot implementation for a particular use case, please contact us, and we would be happy to jump on a call, storyboard a use case, and work with you. We are adding quite a number of support, like adding univariate support for example, if you have uncorrelated signal, a single signal that is coming from an asset that you want to know anomalies on, we do that. We already have streaming support. We were actually going to do as a monthly release, but we already have a streaming support that is released. You can find that in the, we will add that to the product doc. We have a way of actually, you could use OCI streaming service and OCI Service Connector Hub and OCI functions along with OCI Anomaly Detection to point your streaming data to OCI Anomaly Detection, and the resulting identified anomalies you can point to another stream if in case that is a stream that you want that to observe the identified anomalies and trigger business workflows. We do have quite a number of other capability expansion, like utilizing categorical variables from the asset, and also enabling both training and detect using GPU to make your training faster. We are also adding other kernels as we find based on our engagement with customer. We do see variety of problems where different kind of algorithms are needed for solving those problems. So we are adding those capabilities to expand the capability of our product. And we are working on these three, V3, V4, and V5 are in the R&D mode, but the V1.1 to V2 will be coming in the next 6 to 8 months. If you have a problem that you want to do pilot now and it's going to go into your production mode in the next 6 months, then by then you will have all of these capabilities as a part of the product. We do, we are also working on a non-time series anomaly detection, for example, outliers in your business data, and that's also going to be a capability added to this service as we move forward. And we do have quite a number of automatic annotation and user feedback focused capability addition, where if you have historical data, but you know there are anomalies happened, but you don't have that annotated, we have a particular innovation with which we can automatically annotate them, and they, based on the machine learning model, and then present it back to you for you to review, and then take your feedback and then use the data to build the right model for you. So that's a quick rundown of the roadmap. If you're an OCI customer, you will find anomaly detection in the OCI console and analytics AI menu item and anomaly detection. you can pretty much do everything that Jason was showing during the demo. And as Jason showed, we do have a live lab with lessons with the sample data that you could actually go through those lessons to see how you can use the product from end to end. And I also saw quite a number of attendees saying that they are interested in a hands-on training. We will schedule something like that in the near future. So with that, this is my last slide. I believe Kenna has actually taken all of these like different blogs and the reference architectures and the product documentation. She posted it on the chat with the Q&A window. So please review those. And if you have any questions, and if you want to storyboard any use case or talk about how you can use anomaly detection for your business problem, drop me a note at this email, and I will immediately follow up with you to learn the use case and help you use the service. With that, let me see if there are some Q&A questions that we could answer. Okay, so Rich, I see a question from you. Is there an extra cost for the service, or is it free with ADB? I'm assuming you mean autonomous database. So the service, actually, you can see the pricing of the service in online. So the way that we have priced OCI anomaly detection is that the data store, for example, if you have ATP or InfluxDB or object store in your OCI tenancy, you could use the service OCI anomaly detection in the free tier. So there is a large free tier, meaning that all the training, all building of the model building is free. As you know, model building is where it is very compute intensive, and we are giving it away for free because we would like you and all our customers to actually build the model as many times as you need to find the right model for you. So the model training is not charged. There is 1,000 detect calls. So every time you say you have built a model and you like the model and you're starting to send recently collected data for identifying anomalies, there is a detect transaction, and for first to 1,000 detect transaction every month is free. That is a free tier. So you can start using this service for any of your pilot experimentation without seeing a bill on it. But once beyond that 1,000 transactions, we do have a pricing of 25 cents for every 1,000 transactions. Again, it's extremely competitive compared to what is out in the market. Let us know. I don't see, given the number of customers that we are working with, I don't see pricing as even a discussion point at all, given the type of pricing that we have. So please contact me if there is a use case and you want us to help you on how to use the product with the ATP based data and help you to identify the anomalies. Are there any other questions, Jason, that we want to touch on?
I think that Albert asked, can we use the nav detection on the login analytics source?
Got it.
To detect a problem in that. I already answered that we have one internal OCI user case, try to use our service to detect, to monitor the cloud usage from the log. So yeah, we can definitely connect it with you offline to understand what is the problem you're trying to solve and what kind of data it looks like, and we can help you to move forward with that.
Yeah, exactly. So the log analytics is something that we come across quite a bit because it's a timestamped data. So if you have a particular, we would love to work with you because we are working with customers that are having such a data. So contact us and we can storyboard the use case and help you to see how you can use OCI anomaly detection for that particular problem. I don't see any other questions. Are there any other questions that I can help you to answer? And while we are doing Q&A, Kenna, maybe you can bring up the poll, the last question on the poll.
Yeah, there's a question in chat, I think, that someone was having trouble copying over. So
let me
pull that up for you. So Ravi was asking, can this be used to detect anomalies in the OCI instance resource abuse? Recently, I came across a situation where one of the OCI instance got infected by a coin miner, causing 100% CPU outage, causing service outages of the client. Can those situations be detected using this anomaly detection?
Yeah, so we are working with the OCI team for similar use case. So if there are metrics, for example, the minute by minute or second by second service consumption metric that is collected on this, we can definitely apply, apply the OCI anomaly detection to identify. So please, send me a note and Ravi, and we can actually connect on this use case and help you to solve the problem by taking the last 3 or 6 months data and help you to see how you can use the OCI anomaly detection.
Excellent. All right, I don't see any other questions coming through, but I will invite folks, if they have questions that come up later, please reach out to Viji, go post on the CCC forums. This will be reposted with the replay and the slides and resources as well on the forums, so there'll be more information. And I hope you can join us next week and further events. And Viji and Jason, I hope to have you back for more updates on anomaly detection and more AI updates in the future.
Thank you.
Thank you.
Thanks, everybody.